Good day. So welcome to this online video. So the main purpose of this video is to discuss lesson number 1 of educational statistics. So our lesson number 1 has something to do with basic statistical concepts and operations. So in this topic, I usually ask the students to tell something about their thoughts about statistics, and these are the summary. So some students thought that statistics causes much anxiety for them. Some think that it's a collection of formula, it's a numbers or all other mathematical ideas connected in statistics. But of course, for me, these are all misconceptions because unlike other mathematics, statistics is really applied in everyday life. We always claim that in mathematics class that we need to learn math because it's applied in everyday life. So now I'm showing you that statistics is actually in everyday life. So an example is when a doctor records physical examination. So doctor applies statistics because the doctor cannot give you prescriptions when he did not analyze, of course, the findings in your laboratory result. Another is a teacher records the examination scores of the students. This is for the teacher to know whether the student performed or do not perform in his class. So this is also his way now to determine whether he needs to do an intervention to the students. So it is a way for us teachers to compute for our students' grade so that we can determine now whether they passed or they failed the subject. So mind you, not only mathematics teachers use statistics. All teachers use statistics in computing for the student's grade. Another is in business. So managers make decisions not by their instinct only. So in a company, they have their data analysts for them to guide whether, for instance, they have to come up with more products, they have to agree for a partnership of other companies, they have to purchase materials, equipments, and all other things that has something to do with their business. Okay, so our objective for this topic is the following. So we have to define terminologies related in statistics, to explain and identify different types of variables, to explain and name type of measurement scales, to differentiate terminologies that are related like samples and population, statistics and parameter, descriptive and inferential, categorical and numerical, discrete and continuous. Let's start with the first one. So what is statistics? So as presented in the introduction, statistics is applied in everyday life. Basically because it is a branch of applied mathematics. Aside from that, it is also a science that involves the research process. So it is also applied in doing research. So these are the different process. So we have the collection of data, organization of data, presentation of data, analysis of data, until to the interpretation of the data. Now let's move to the division of statistics. So I have here two phrases. The first one is the game of chance and the other one is political science. So these two phrases has something to do with why we have descriptive statistics and inferential statistics. So the first is political science. So political science is what? What can you say about political science? So actually, the reason why we have descriptive statistics is because of the effort to define what is political science. While for game of chances, So because of game of chances, so we have the field in mathematics called probability. And probability is the foundation of inferential statistics. So how do these two divisions differ from each other? So let's start with the first one. So for descriptive statistics, obviously the main objective why we are using this is to describe the data. So after collecting the data, after presenting your data, you come up now with a summarized value, and this now describes the group's characteristics. So you are applying descriptive statistics. So the commonly used are the measures of central tendencies, measures of variations, which will be discussed in a separate lesson. And then we have here examples. So the first one, the average score of the students in 100 item test score is 83. The passing score is 75. And the next example, the average score of the students in 100 item test score is 65 and the passing score is 75. So we actually have here three numbers for the first example and three numbers for the second example. That's 183 and 75, 165 and 75 respectively. So the descriptive statistics here is, for the first one, it is 83. It's the average score. Because of this number, you were able to know that the student passed the test because it's above 75 and 75 is the passing score. While in the next example, because you know that the average score is 65, then it means that the students did not pass the test. So this number is very powerful that you cannot determine whether they pass or failed if we do not know this number or the average score of the students. So that's how descriptive statistics works. Now, for inferential statistics, so when we come up now, of course, with also collection of data, presentation of data, analysis and interpretation of data using descriptive statistics, and you want to give more meaning to your data, so you make predictions and inferences now with your analysis and interpretation of your results. So the main objective why you are using inferential statistics is to make inferences. We have commonly used tests. So we have the t-test, z-test, analysis of variance, chi-square, and Pearson R. So this will be discussed again in a separate chapter. Okay, next. Constant and variable. So I just consider, of course, constant because I want to ask a question later. So the first one is constant. Simply, these are terms that these terms are not new to us. We know that constants means it do not change or it do not vary. While for variable, it is a numerical characteristics or attributes associated with the population being studied. So it can vary in values either in quantity or quality. So do you think we have a constant variable? Or since it's constant, then it's not a variable? Okay, well, what are the constant things or constant variables that you know? So we encounter, for example, constant values in other subjects like the value of pi, 3.14, the boiling point, or the value of E in mathematics, and all other constant values. So how about your age? Do you think your age is constant? Okay, let's consider this. Your sex is male, and or it's a female. So is your sex a constant variable? So when we are talking about individual person, you might answer that, of course, my sex cannot be changed. So we have, of course, the process of um, gender to be gender to be other gender, but for the case of sex, because it's biological, it's constant. But in his statistics, when we say that it is constant, it doesn't mean that because your sex is male or you're female, it's already a constant variable. Because remember, we are using statistics when we are analyzing a group of person. It's not only for an individual person. So if we consider now one whole class, and I consider that the respondents of the study will be restricted to male students only, then sex as variable is constant in the study. Or if I consider that all the ages of the students that will be included in the study will be the students of age 16 years old only. So it has a different perspective when we talk about statistics, applying statistics, and also if we talk about an individual only. Okay, now let's also consider the types of variables. So we have categorical. Other than categorical, we also call it as qualitative data. Maybe you are more familiar of qualitative data. So it is classified according to some attributes. And examples are gender, political preferences, and blood type. While numerical valued is another type of variable, or sometimes it's called quantitative variable, or you are more again familiar with quantitative variable. So it is classified according to numerical characteristics. So it differs in amount of degrees. So we have height, age, numbers of children, and others. So if the variable now is a numerical variable, it can also be classified whether it is discrete or continuous variable. It is a discrete variable if it is obtained by counting. So example, number of males and females, number of students with blue eyes, number of dengue patients, and others. While if it is continuous variable, the values are obtained by measuring. So they have value in some interval of real number, which means that it is possible to come up with a decimal number. So we have temperature, height, weight, distance. So let's summarize that. So we have here types of variable. So variable can either be qualitative or quantitative. So if it is quantitative, we can classify it as discrete or continuous variable. So which means that if the variable is qualitative, do not classify it as discrete or continuous anymore, because only quantitative data can be classified as discrete or continuous. While if it is discrete, it means that it is obtained by counting, while if it is continuous, it is obtained by measuring. We also have other classification of variables. So it has something to do with experimental classification. So if it is according to the function in the experiment. So we have the independent variable and the dependent variable. So the independent variable are the controlled or explanatory variables, while dependent variables are variables that are influenced by independent variables. And then the next one is mathematical classification. So it's similar